Thanks. While I get technical help, which I desperately need, I maybe start with the introduction. Hi, my name is Olaf von Seelen from trinckle, and I have with me Sven Gaeder from the Deutsche Bahn. We had the pleasure to hear already a lot about what Deutsche Bahn is doing in the area of additive manufacturing, and now we want to deep dive into one specific topic, which is around fixtures and the design approaches that Deutsche Bahn is taking, and we from trinckle, we have the pleasure to help out to do the design process more efficiently. And at some point, you hopefully will also see that on the slides. Sven will start a little bit to describe what the typical problems at Deutsche Bahn are. And then as soon as we have described this problem a little bit for you guys, so you understand the pain points that Deutsche Bahn have, we will dive into the software to see in live how we try to solve these problems. So stay with us for a little moment. We're still seeing I see here a nice presentation, and you see the PowerPoint version of it, which is maybe not the perfect thing for you guys to follow.
But I can continue with my introduction.
Thank you very much. Here. There it is. Okay, Sven, take over.
Thank you very much, and thank you, Ole, for the nice welcoming. I'm a 3D printing passionate. I'm in the business since 2016. Not much shorter than the company-wide project from the Deutsche Bahn is existing. As you maybe heard in the previous talk, the company-wide project in the Deutsche Bahn is founded in 2015 with the main focus on spare parts and obsolete parts. Because we need a lot of spare parts in the Deutsche Bahn. And you see, meanwhile, we are doing a lot of stuff. We have more than 500 applications printed, over 100,000 parts. And we use a lot of technologies and different materials. And we can go on. Here you see some focus groups we are focusing on, and we want to use all, or to earn all the potential 3D printing can bring into the Deutsche Bahn. As I said, first of all, obsolete parts is a big focus. Then we started to integrate some function together to make out of 10 parts maybe one part again. But even we have some cases where we could change the manufacturing process from milling to AM because it's just cheaper. And one good stuff is always to have laboratory trains, for example, where we have special use cases. For example, a special cable cladding where we can use 3D printing for this stuff. And the main focus today will be using 3D printing for tools and fixtures because in our maintenance we have a lot of potential for optimizing our process. The people, they need easy solutions and repeatable solutions. Maybe you can imagine if you found something like this working place. This is typical for us. We have to maintain some components, and on the right side, on the bottom, you see the pump from the coffee machine here. And if you want to mount all the parts together, you see it's not laying flat, it's just clicking around. It's not easy to mount it. So the idea was to have a great fixture, to put it in a stable position. So this is the easy part. It's not very high in quality or something necessary. It's just necessary that you can put it on the table and it's not clicking around. And so this is a ground idea, and we think we have a big potential all over the Deutsche Bahn where we can find a lot of these ideas. and use cases. And now we have the little problem. We are all over in Germany. We are not. Don't have a facility just in Frankfurt or in Berlin. We have a lot of little facilities, and they get more and more little printers. But they don't get more and more designers to design a AM part like this. You need some experience for this. You even need the right laptop, the right hardware, and you need always the right software. And if you can imagine, if we license a lot of CATIA or Autodesk, also it's getting very expensive, and that's the reason why we have a great partnership since a few years with trinckle, because they have a good solution, a web-based solution where everyone can design something like this in an easy way. So I hand over to Ole.
Yeah, thanks, Sven. So, Sven described the potential and the bottleneck at the same time. So 3D printing offers the potential, but the design capabilities and capacities in an organization, not only at Deutsche Bahn, quite often is the bottleneck, which we try to solve. So what we try to do at trinckle from the software side, we try to make this design process easier and enable more people to contribute. How do we do it? We basically try to put design workflows into automated software pieces. If you have been here 1.5 hours before, I talked already about medical applications where we use this kind of system. Here in this case, it's all about jigs, fixtures, tooling. Why is it such an amazing use case? Because it's super low-hanging fruit for additive manufacturing. Not only at Deutsche Bahn, but generally in the industry, jigs, fixtures, tooling make a very good entry case for using and establishing additive manufacturing methods in your organization. And for that, we, especially for those fixture applications where you saw one of those, we established a product which is called Fixturemate, and it's a dedicated workflow to design those fixtures easily. So we look at one of those assembly fixtures. Here, another example, an assembly fixture to assemble these two components, and now I want to do a risky thing after I already had problems to bring my slides on the screen. I want to change quickly and show you software in live, actually. So it's always a tricky thing to do something like that during a fair, but I want to show how easy it is to design such a fixture. So the starting point in our process would be to upload the part, the workpiece, that you actually want to hold. And the thing that you do then is you bring it into the orientation that you are heading for. So you bring this part, the part that we saw in the photo earlier, to the base plate, align it and orientate it in the way you want it. Then you select a base plate for it. So either this could be a 3D printed plate in a rectangular form, or maybe a convex hull to minimize the material that we need, or it could be also a machined part, a conventional manufactured component like this perforated metal board here. After you've done that, you would need to create some support structures, and I just want to show you with a few clicks how easy it is to create those support structures. You see there's a lot of adapting it with the mouse. It's quite simple. For example, now I want to set the height to a certain level here, and I can do that with a few mouse clicks. I just place one other support component, maybe a conical one here, and define the outline of it, and it creates a nice structure for this. So easily done. Now you see it's still interfering with my object, so I don't have a nice negative yet, but that can be done in the next step. I subtract the workpiece from the support structure, and it now creates a nice cavity. If I hide this part now, the workpiece, I will see this negative, how it is created. And this is actually the one single task for a designer that really is really annoying in a regular CAD tool, to design these negatives. And here in our solution is really easy to do that. I just add one other component to hold it, just to show you which flexibility you have. I just create a polyline now to create such a negative. So you see how easy it is done. You want at the end also connect those support elements to my perforated board. So I'm selecting a few of these holes quickly to make a nice interface connection to them. So you see how easy it's generated and then exported as an STL file. So a fixture design like that would take 2 or 3 hours maybe in a regular CAD tool. Within our tool, 50 minutes, 20 minutes, something like this. And the idea is not only to enable the CAD professionals to it, they could do this job in SolidWorks, they could do this job in CATIA and so on, they can do even better than that. But here it's more about enabling other teams at Deutsche Bahn and other customers to contribute in this. So here, this I showed you, here you see a little bit how this milk pump design process would look like in our tool. I just brought a couple of use cases here. You can see what we can do with 3D printing. Here, for example, a fixture for a very simple welding process, for instance. Try it out to use 3D printed fixtures for this too. Or some cases from the metrology departments. So when you have a CMM measurement process, you need to hold this workpiece in a stable position, in an orientation that you would like to measure, and then this you can easily do in a 3D printed fixture. Here you see an example from the world of CT scanning. So to bring a part into an orientation that it's easily to be scanned by a CT, also 3D printed fixtures for that is a really easy idea. And then we discovered with Deutsche Bahn another use case which we also brought here live.
Correct, yes. Yeah, you can imagine we have a lot of internal logistic, and it's not easy every time to have a good transportation case for a lot of different parts. And if you have a box where sometimes the things are laying bad together and clicking together, bumping, then you get bad parts and it's not possible to use them anymore. So we decided, or some colleagues from us said, okay, we have an idea to optimize this, and they put a grid into a box, and the easiest stuff for FixtureMate is now to have the right mounting fixture for the parts. So as you have seen it from Ole, just upload the part and make the fixture the negative of the fixture, but there was a little problem because FixtureMate didn't have all the boards we knew that we needed. For example, the grid was not a standard board or ground floor for FixtureMate, but thanks to trinckle, we have now this customized board in trinckle. So it's an easy way for them to integrate it for some customers to optimize their process, because now we have the possibility just to choose the grid as a ground floor, and then to have the supports as a negative for the parts, and even they get the pins for the grid so that they are just printed out and clicked in.
Yeah, and this is actually the beautiful part about the dynamic software development, because if we learn from a customer something like this, a requirement like this, it's a web-based tool. So it's very, very easy for us to update it on the fly for new customer requirements. And of course, this is something we learned at Deutsche Bahn, that this could be a potential use case for additive fixtures. And then it's easy for us to bring it into the software to enlarge. I showed earlier the perforated board. Now we have the grid as well. So it's easy to establish a new process and a new use case for additive manufacturing. And we learned something in our software development that we can then also present to other customers. So it made our software product even stronger. A few more cases. Go, no-go gauges, for instance, typical inspection fixtures for additive manufacture tools. So for all the metal people in the room, maybe that's a smart way to do some very simple tests for your metal parts. At the end of the day, what we try to solve with FixtureMate is we try to enable people without the CAD and AM expertise to design those. We reduce the manual workload, and therefore we can speed up these processes. You don't have to go past your engineering department to solve these jobs. and you can easily spread it over the different sites that Deutsche Bahn or your organization happen to be. If you want to try this, please either scan this or come to our booth. We have flyers there where you can go to a landing page for FixtureMate. You can try it out. I invite everyone to try it out. It's really simple. If I can do it, and with my technical expertise, as you saw at the beginning, you can definitely do these designs as well. So we invite you to try it out and experience if in your organization can be fixtures designed easily. Thank you very much for your attention.
Thank you both. Thank you for